Alright, we're going to do the 4-1 notes today. You're going to need your textbooks open to page 214. You're going to need a ruler and a couple different colored pens. I'm going to use a highlighter for all of my graphs to make my axes and then different colored pens for my points. So make sure you have all of those things. We're going to start chapter 4. Chapter 4 we're going to start talking about different kinds of equations. All of them are still going to be linear, which remember from last chapter means when you graph them they form a line. They can be written in standard form, which is ax plus by equals c. And we have more than one way to graph them. We're going to learn about slope-intercept form, and that's a really easy way to graph these equations as long as you can write them in slope-intercept form. So today's lesson is called Graphing Equations in Slope-Intercept Form. The first thing we're going to do is we're going to write in slope-intercept form. I'm not going to actually write the definition. I'm just going to tell you that slope-intercept form is y equals mx plus b. You've seen this before. M is our slope, which we know slope is rise over run, or the change in y over the change in x. B is our y-intercept. Think back to last chapter. Y-intercept is where it crosses the y-axis. So when we write an ordered pair, it doesn't go left or right at all. It only goes up and down. So the first coordinate is 0, and then we're going to have a y value for our up and down. Over here I tell you that m is slope and b is y-intercept. That's called a parameter of the equation. Basically that means it defines what the equation means, so if either of those values change, the graph changes. Alright, let's get started. An example of slope-intercept form being graphed would be like y equals 2x plus 6. We have our y and our x just like up here, but instead of m, they tell us that m is 2. Or I'm going to write it as 2 over 1 because I have to have a rise and I have to have a run. This means it's rising 2 and it's running 1. The next thing is it tells me that b, or my y-intercept, is 6, which means if I look up here, I'm going to have an ordered pair at 0, 6. So the first thing you do, grab your ruler, draw on your x and y axes. I'm going to draw mine in the y-axis right down the middle. And I'm going to draw my x-axis towards the bottom because I know I'm already up 6 and I know I'm going to have to rise 2 more. So I'm going to draw it towards the bottom. Remember to label your origin and your axes. Okay, so taking a look at what our information already gave us, we know that we have an ordered pair at 0, 6. So start at the origin, go up 6, and draw a point in. Don't forget to label. Alright, and I know to find my next point, I just use my slope. So I'm going to rise 2 and run 1. Rise 2, run 1. That's one of the points on that line. And I know I'm over 1 and I'm up 8. Okay? How many points do you need to make a line? 2. In this case, in order to keep my line really straight, I'm going to do 3. So I start at my second point, go up another 2 and run another 1. That puts me at 2, 10. That's just going to make sure that your line is where it needs to be. Okay? Go ahead and draw in your line. Make sure you draw all the way through. Put arrows on the end. Now, something else, now that we've already graphed this, that we can find is the solution. And if you remember from last chapter, a solution is where our line crosses the x-axis, so this point. And I'm going to label it. This is -3, 0. And that's my x-intercept, my solution, my root, or my 0. Do you remember all those names for the x-intercept from the last chapter? Alright, go ahead and turn your page. Let's take a look. This time it says, write and graph the following equation in slope-intercept form. This is asking for two things. The first thing we have to do is write the equation. The second thing we have to do is to graph it. So let's start by writing the equation. So I know I want it in slope-intercept form, which is y equals mx plus b. M is slope, b is y-intercept. My slope is 3/4, my intercept is -2. So I'm going to write this as y equals, I'm going to replace m with 3/4 x plus a -2. Now I know if I'm adding a negative, it's the same thing as just subtraction. So I'm going to rewrite this as y equals 3/4 x minus 2. That's the equation in slope-intercept form. The second thing I'm going to do is I'm going to graph it. I know I'm going to have a point at y equals -2, or my intercept, so it's 0, -2. And I know I'm going to rise 3 and run 4. So let's start graphing. I'm going to draw my y-intercept a little bit to the left this time because I know I'm going to have to start at the y-axis, but I'm going to have to run 4, which is kind of this way. So I'm going to start towards the left. Okay, and then my intercept is at -2, but I have to rise 3. So I'm going to start a little bit towards the bottom, but I'm going to leave enough space for my intercept, which is at -2. Label your axes in the origin. Alright, so my intercept is at 0, -2. So I start at the origin, go down 2, mark your point. Alright, now I have to rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4. That's my second point. I'm over 4, and my point would be 4, 1. Alright, let's put one more in there so that when we draw on the line it's accurate. So rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. Mark your point. So if I count, I should be at 8, 4. Alright, let's go ahead and draw in our line. Okay, do you see how my solution is not at an exact intersection? So it doesn't have a integer for a value. We're not going to worry about that for this graph because it's not as obvious. So it'd be kind of hard to estimate where it falls. Let's turn to the next page. When an equation is not written in slope-intercept form, it can be difficult to graph. Sometimes you get big numbers or you have negatives and it's just hard to picture it in your head and it's hard to pick out where your points should go. And so it's easier to rewrite the equation in slope-intercept form and then graph it. We have several tools. We have, if it's written in standard form, you can find its intercept and then graph it. You can make a table and choose x values and then find your y values to make ordered pairs and then graph it. This is a little bit easier and it's a lot quicker than making that table, and sometimes it's a lot easier than finding your x and y intercepts. So let's go ahead and start here. We have 3x plus 2y equals 6. This is standard form. We learned about that in chapter 3. And so there are two ways that we could graph it from standard form. Find the intercepts or make a table. Today, we're not going to do either of those things. We're going to rewrite it in y equals mx plus b, or slope-intercept form first, which is going to tell us our slope, it's going to tell us our y-intercept, and graph it just like the last two graphs that we've been doing. So I want it to look like y equals mx plus b. Right now, I have 3x plus 2y equals 6. I want to get y alone on the left side. So to do that, I have to get the 2y alone. I'm going to get rid of my 3x. Right now it's positive and it's being added, so I'm going to subtract it from both sides of the equation. They cancel over here, and I'm left with a positive 2y equals, and I'm going to write it as negative 3x plus 6. The reason I did that is because I have mx first, so I want my 3x to come first, then plus b, which is a constant, because it's, remember, it's just our y value, our y-intercept value. So that's why I wrote it as negative 3x plus 6. So the last thing I have to worry about is that up here y is by itself, and down here there's a 2 next to it, and it's being multiplied. So to undo that multiplication by 2, I'm going to divide each term by 2. I can't just choose which ones I want to do. I have to do it to each one. So 2y divided by 2 leaves me with just y. Negative 3x divided by 2 can't be simplified. 3 and 2 are as simple as it gets, so I'm going to leave it as negative 3 over 2, then times x. Don't write it as a decimal, because then when you go to do your rise over run, it doesn't make a lot of sense, because you're like up 1.5 over 1. It just kind of gets goofy on our graph. It's just easier to leave it in fraction form. Then plus 6 divided by 2 is just 3. So my equation in slope-intercept form is y equals negative 3 halves x plus 3. Remember that negative 3 halves is my slope, or my rise over run, so it's going to fall 3 because it's negative, and then run 2. 3 is my b or y-intercept, so its ordered pair is 0, 3. So now we have all we need in order to be able to graph it. I'm going to draw my y-axis right down the middle. We're not running too far, so it shouldn't go off of the graph for us. Okay? And then for my x-axis, I'm going to draw it up a little bit. It has to be able to fit 3 above it, so I'm going to leave 4. But I remember I'm falling 3 each time, so I want to have enough room below the axis that I can show that fall before falling off the graph. So start with your y-intercept. Start at the origin, it's at 3, so I'm going to go up 3. Okay, make sure you label. Then I'm going to use my slope to find the next point. So I'm going to start here, fall 3, then run 2. That point puts me at 2, 0. I'm going to do one more, fall 3, run 2. That puts me at 4, negative 3. Go ahead and draw your line through those 3 points. Okay, then we're done. Now, fortunately, one of our ordered pairs falls on the x-axis, which is our solution or root or 0 or x-intercept. Okay, let's turn to the next page. Now, there are some special conditions when we're talking about different kinds of graphs and different equations. Remember when we're talking about horizontal lines and vertical lines, they had special values for their slopes. Horizontal lines have a slope of 0. Vertical lines have an undefined slope. So right now we're just going to worry about horizontal lines. We're going to say horizontal lines have a slope of 0, which remember means that it is a number, or a 0 over a number, because we can divide into 0, but we cannot divide by 0. Before we get too far, I'm going to have you come down to the bottom of this page. It says vertical lines have no slope or undefined slope. Which means a number over 0. So when we're talking about 0 over a number or a number over 0, this means it rises but doesn't run. Now for our horizontal line, this means that it doesn't rise, but it runs. Okay? Horizontal lines can be written in slope-intercept form because they do have a slope. It's 0. So when I look at it, I write it as y equals 0, because remember it has a slope of 0, x plus b. If I take 0 times x, I just get 0. So I get y equals 0 plus b, or 0 plus b just gives me b. So I have y equals b. You've seen this before. If you get an equation that looks like y equals negative 3, that's in slope-intercept form. It just doesn't have a slope, so it doesn't have an x value that changes with it. It just changes however far you run. So let's take a look. If I have y equals negative 3. Remember from up here, negative 3 is my b. So my intercept is at 0, negative 3. And then my slope equals 0 over a number. So it's not rising, but it is running. I'm going to change that number to 1. You could choose whatever number you wanted because it's still going to have a slope of 0 no matter what you put underneath of that 0. I'm going to just go with 1 for our graph because it's kind of small. So let's start graphing. I have an intercept and I have a slope. So I'm going to draw my y-axis right down the middle. And I'm going to draw my x-axis a little bit up towards the top because I know I'm going to be at negative 3 and I want to have plenty of room. Label your origin. Okay, so I have my first ordered pair at 0, negative 3. So start at the origin and fall 3. That's my first one. Now let's do our slope to find our next points. So I start at the point that I have. I'm going to rise 0 so I don't go anywhere, but I'm going to run 1. There's another one. What if I start here again? Rise 0, run 1. Rise 0, run 1. You should notice that it's making a horizontal line. Which we've talked about this before, so that's what we wanted. It says horizontal lines have a slope of 0. So these can be graphed using slope-intercept form. These ordered pairs would be 1, negative 3, 2, negative 3, 3, negative 3. Okay? There is no x variable. This means that it doesn't touch the x-axis, unless it is the x-axis, which I don't think we're going to run into that today, so we'll talk about that in class on Tuesday. Vertical lines have no slope, can't be written in slope-intercept form, so we're not going to worry about them today because it's irrelevant to what we're learning about. Turn to the next page. Sometimes, instead of giving you the equation and saying, here, graph this, they're going to give you the equation and say, hey, write the equation for this graph. We've seen this before. When we were talking about direct variation and proportional and non-proportional lines, you had to decide what its equation was. This is going to be a little bit easier way to do it. There's a few more steps, but it's easier to understand. The first thing you have to do, locate the the y-intercept, or b. Pick one more point on the graph. Using the y-intercept, and second point, you're going to find the slope. And we know to do that we take y2 minus y1 over x2 minus x1. After that we'll have an intercept and we'll have a y-intercept which is b, and we'll have a slope which is m, and we can use that to write it in slope-intercept form, which is y equals mx plus b. So let's try an example. First thing I need to do, find my y-intercept. Looking at this graph, I can see it's at 0, 2. Okay? B equals 2. Second thing I need to do, pick one more point on the graph. It'd be best if you chose really obvious points so that way you don't have to, that you have no doubt that you chose a point that actually falls on the line. For us, I'm going to choose negative 1, 0, this intercept. Okay. The third thing I'm going to do is I'm going to use these 2 points to find the slope. Now, remember it's y2 minus y1 over x2 minus x1. I'm going to use this as my second point, so y2 is 0 minus y1 is 2 over x2 is negative 1 minus 0 is my x1. I had to choose negative 1 first because 0 came first up top. 0 minus 2 gives me negative 2. Negative 1 minus 0 is negative 1. Negative 2 divided by negative 1 is just positive 2. Remember, a negative divided by a negative gives me a positive. 2 divided by 1 gives me 2. M equals 2. Now I have my m, I have my b, and I know what slope-intercept form looks like, so I can write the equation. Y equals, I'm going to replace m with 2, x, plus b is 2, so I have y equals 2x plus 2. That's the equation of the line. Alright, I want you to go ahead and I want you to try this example on your own. I'm going to give you 30 seconds and then we'll do it together. Okay, we're going to get started. If you need more time, just pause the video and then follow along. So the first thing I have to do, pick out my y-intercept. From this graph, I can tell that b equals 1, and my intercept is at 0, 1. Second thing I need to do, pick another point. I'm going to choose this one because it's really obvious, and it's at 2, 0. Third thing I need to do, find my slope. So I'm going to use this as my second point, this as my first. I'm going to take 0 minus 1 over 2 minus 0. I get negative 1 over 2. This is a good thing because I can tell that my graph is moving downward, so it makes sense that my slope is negative. Last thing I have to do, write my equation. I know that b equals 1, m equals negative 1/2. So my equation is y equals, replace b with 1, x, plus, negative 1/2. And then plus 1. So I'm going to have y equals negative 1/2 x plus 1. That's the equation of that line. We have one more example. Again, I'm going to give you a few seconds to try it out, and then we'll come back and work on it together. Alright, we're going to get started. If you need more time, pause the video and then come back and compare it with us. So, first thing I need to do, find my y-intercept. I have a y-intercept at negative 2. So my point is at 0, negative 2. Second thing I need to do, pick one more point. This one's pretty obvious, so I'm going to choose that. I'm going to say I have another point at 1, 0. Okay? Third thing I'm going to do, find my slope. First point, second point. So I have 0 minus a negative 2 over 1 minus 0. 0 minus a negative 2 is the same thing as 0 plus a positive 2. So I get 0 plus 2, which is 2, over 1 minus 0, which is 1. My slope is 2. Okay, now I have my slope and I have a y-intercept, so I can write it in slope-intercept form. I'm going to say y equals m is 2, x, plus b, which is negative 2. Now I know that plus a negative is the same thing as just subtraction, so I'm going to rewrite it as y equals 2x minus 2. That's the equation for that line. That's the end of the notes. So you need to go ahead and work on the homework. Try it out. Let me know if you're having any trouble. We'll work on it in class, and good luck.